Okay, so here we have some problems out of test one review. Once again, your problems may be different, so just match up the problem, not necessarily the problem number. So here they gave us a chart. They want us to plug in these values for X, and then let it know. You can use a calculator, of course, let them know or plug in what you get out for Y. So plugging in 4.9 in for X in the problem will get you this value, plugging in 4.99, 4.999, skip 5 because plugging in 5, of course, will give us 0 in our denominator, which is undefined. So that's what we're going to skip right now. Plugging in 5.001, 5.01, and then 5.1. Once again, we found these values by just plugging them into the calculator. Not that big a deal. So now they're asking you what happens or what is the limit of this expression as it goes towards 5. We know when you plug in 5, you get 0 in your denominator, which is undefined. But what is the value going to or approaching when you're talking about going towards 5? Well, what happens here is you look at 4.999, you get negative 0.0278. At 5.001, you get negative 0.0278. So basically leaning on the sandwich theorem or the sandwich theorem property, our answer would be negative 0.0278 for both of these. Leave no room, squeeze it in such a way that that's the only place we have to go. That's what they're approaching. So if you're talking about rounding it out to 4 decimal places, then that's as far as you can go, 0.0278. All right, so whatever those two values are, they should match up and give you that answer. All right, so next one, we want the limit of the square root of 8x plus 8 minus 4 over x minus 8 as it goes towards 8. Well, once again, we know we can't put 8 in here because 8 minus 8 is 0. It gives us 0 in our denominator. So what we're going to do is multiply by the conjugate of the numerator. If I can write my x's. So you're talking about the square root of x plus 8 plus 4 over the square root of x plus 8 plus 4. We're going to multiply both top and bottom by that. So let's look at the numerator first. All right, so we're going to FOIL. So this x plus 8, square root of x plus 8 times square root of x plus 8, which is square root of x plus 8 squared, plus 4 square root of x plus 8, minus 4 square root of x plus 8, minus 16. 4 square root of x plus 8 cancels in the middle. Also square root of x, square root, and then the square cancels, leaving you with just x plus 8, minus 16, which is just x minus 8. So that's our new numerator. So I guess I'll move this down, running out of room. Cut this out the way. All right. And so that's our new numerator. Now we can look at our denominator. X minus 8 times square root of x plus 8 plus 4. Yep. So FOIL once again. That'll be x square root of x plus 8 plus 4x negative 8 square root of x plus 8 minus 32. Nope, I'm going to leave that alone. It's not going to help me. So I'm going to leave that the way it is. So let's go back to our problem with our new numerator and new denominator. We got the limit as x goes to 8. Numerator is x minus 8. And I should have saw this before I did that formula. And we have x minus 8, square root of x plus 8 plus 4 as our denominator. X minus 8 cancels, leaving you 1 in the numerator. Now we have the limit as x goes to 8 of 1 over the square root of x plus 8 plus 4. Now we can plug in 8. Eight plus 8 under the radical is 16. Hold on, I'm gonna get this out of the way. All right, square root of 16 is 4. 4 plus 4 is 8. So that's our answer, 1 over 8. All right, let's look at the next one. Let me make room. Got all this stuff, needed more room than I thought. All right, so here, once again, cannot plug in 2 in this denominator, give us 0 in the denominator. So I can factor this out by using a difference of squares, difference of cubes, excuse me. Difference of cubes says you have x cubed minus y cubed, x plus y, x squared minus xy plus y squared. So that's that formula. And if we look at what we have here, we have x being cubed minus 2 being cubed. So we're going to plug in x and 2, x for x and then 2 for y. So it'll be x plus 2, x squared minus x times 2, which is 2x, plus 2 squared, which is 4. And hold on, I did my signs wrong. Sorry about that. It's supposed to be the same. So it was a minus, then it should be a minus, and then it should be opposite with a plus in the back. So let me do that. All right, there we go. Then bottom, we got x minus 2. These cancel. X squared plus 2x plus 4. All right, so once again, I messed around and put a plus right there when I should have been a minus. So my apologies, but we have this, and now we can take the limit of that as x goes to 2. Go ahead and plug in 2. Two squared is 4, 2 times 2 is 4, 4 plus 4 plus 4 is 12. All right. And then it says write a simpler function that agrees with the given function at all but one point. So basically, you're talking about this right here. So g of x is equal to x squared plus 2x plus 4. So it's that second part. All right. All right, let me do this real quick. Trying to get my problem back. Didn't know I was running it into. Oh, I did all that? Okay, well, never mind. All right. All right, so okay, it's just a T right there. So the next one asks us to find a vertical asymptote of S of T equal to 2T over S of T, the sine of T. All right, so we're talking about the vertical asymptote. That's where your function is, for the most part, is where your function is undefined, and it creates this imaginary line that the graph will never cross. And so you can always look at a graphing tool, use a graphing calculator, use a graphing app or website like Desmos to confirm what you're talking about. But basically, you want to know, when is this denominator equal to 0? Because that 0 in our denominator of a fraction will give me undefined. So the times that sine will give you 0 will be when t is equal to pi. So if you're talking about the unit circle, sine is equal to y, cosine is equal to x, as far as your xy coordinates. So here are the places where you have 1, 0, and then here, -1, 0. All right. So you want, and when you look at the graph, and I can show you in a second, just let me pull it up. All right, so that was the wrong one. Go to graphing calculator. So we're talking about t divided by sine of t. Oh, that's right. Can't use t, got to use x. So if you notice, you will have, at 3.1415, if you were to go ahead and graph it out or trace it, you have these imaginary lines that the graph never cross, these vertical axes, vertical asymptote, excuse me, at pi, except for right here. So I'm showing you that in a second. So you see right here at 0, and let's see if I can get it right there. See how it says 0 undefined. Notice it's not a vertical asymptote, but there is an open circle there. It's undefined there. So let's go back. But this is what I'm talking about, taking the graphing calculator or graphing Apple website to confirm what you know to be true. Because you may not have known that, about 0, but if you notice, you keep going out every rotation of pi. So this is pi, then this would be 2 pi, then this would be 3 pi, this would be 4 pi, 5 pi, 6 pi. So every rotation of pi will give you this vertical asymptote. And so except for when 0, you saw that we just had an open circle, not a vertical asymptote. So we see the best way how they want you to answer this. Yep. So you write t, since I got so much red, T is equal to N pi. And then it says where N is not equal to 0. So that's what you would put in, this would be in the box, and then this would be in the box. Okay, so hopefully that made sense. Once again, your Y is 0. And so if you look at the unit circle, those are the places where Y will be equal to 0 for sign. And that's pi, and then every period of pi. So that's why you have N. So N just represent your integers, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. And then except for when N is equal to 0, because remember we saw that it was just an open circle there. It's not an asymptote. Okay, hopefully that made sense. If not, feel free to ask again. And it should have an E right there. Then the last one that was asked about. All right, so let me erase some of this stuff. I messed it up. So it should be 6x plus, okay, 6x plus x minus 1, 4x squared minus 2x minus 2. All right, so once again, plugging in -1/2, give us 0 in our denominator. Can't do it. So the best way we can handle this is to first see, is it possible to factor both numerators and denominators? So looking at the numerator, I'm looking at 3x. Let this be 2x. Let this be +1 and -1. So it'd be plus negative, yep. Then the next one, 2x, 2x. And -2 plus 1. So it'd be -4, 2, yep. Also, we can factor out 2. I'll do that in a second. So 2x plus 1, 2x plus 1 cancels. Leaves me with 3x minus 1 over 2x minus 2. If we want, we could factor out 2. Not mandatory, but like I said, if you want it. All right. Let's see. We're gonna plug in 1/2. I'll probably leave it in there. So I'll just leave it like that. All right, so now we're looking at the limit. -1/2 coming from the right side. Plug in the 1/2, with -1/2, excuse me. All right, so that's -3/2 minus 1. 2 times 1/2 is 1 minus 2. -3/2 minus 1, that's going to be 2 over 2 over -1. -5 over 2 over -1. So that should be +5 over 2. All right. I left off a negative. Make sure y'all hold on to those negatives. See, nobody told me, nobody warned me, or nothing like that. Somebody's supposed to say something. So that should be a -1 right here. So it's -1 minus 2. And so that should be -3. This is going to be -3. So -5 over 2 times -1 over 3. If you really want to go through the process, -5 over 2 divided by -3. Then that turns into -5 over 2 times -1 over 3. Whenever you're dividing by a number or a fraction, you multiply by the reciprocal. So that's what happened here. Now I have negative times a negative, which is +5 over 6. All right, so looking down at the problem, I noticed I had left off that negative. So my answer is 5 over 6. All right, so now there was one person who sent me something and they were doing some cancellations. So I'm trying to go off of what they did. Give me a second. Where did it go? Here we go. Negative 3/2. Very similar to what we did, but I just want to make sure he saw where it went wrong. So negative 3/2 minus 101. You had this negative 1/2 minus 2. So negative 3, 102, negative 2 minus 2. Okay, so I just want to show you, sir, where you went wrong. You almost got there. So where you went wrong is that you canceled right here. And you can't do that because this minus sign, I mean, that's my sign, this 2 has to go to each term. So if you wanted to do that, then you have to distribute it first and then cancel. Outside of that, everything else is right. You simplified this right as well, but you cannot just do this and then go with negative 1 minus 2. That 2 needs to be distributed once again to each term. And so up here, this turns to negative 5/2. Then down here, what you have is negative 1 minus 4. Negative 5/2. That'll be negative 5. And then if you finish it off, negative 5/2 divided by negative 5. Negative 5/2 times negative 1/5. 5's cancel. That'll be a positive 1/2 as your answer. All right. So that's negative 1, negative 4, negative 5. All right, let me know if you guys have any questions. Take care.